Hello class and welcome to lesson 5.2. It's called expected value. Today we're going to solve problems that's related to expected value, and it talks about, is this a fair game or a fair play? We're going to get into as well. So one thing we need to know, folks, is the expected value is the predicted mean of all possible outcomes of a probability experiment. Okay, so it's a weighted average where the weights are the probabilities. Okay, and we use this to make predictions. Okay, so taking a look at your formula, which is on your formula sheet. Okay, capital E means expected value of the random variable. Okay, is that each value times its probability is added up. Okay, so remember the summation sign means to add. X to the I means each data point times the probability of that corresponding data point. All right, let's take a look at an example and we'll incorporate it in today to see how that expected value works. Okay, a box contains 5 $20 bills, 6 $10 bills, and 4 $5 bills. You pull 2 bills out and keep them if they are the same. Okay, so generate a probability distribution for this game. Hopefully I pulled 2 20s out because that's pretty good. All right, so what we're looking for is our random variable is how much you win. Okay, so that's what we're interested in. All right, so let's take a look at A. Generate a probability distribution. Okay, so let's start with the highest possible win. So the highest possible amount of money you could win is to get 2 5s, right? Or sorry, 2 20s. Okay, so that's going to be a total of how much? $40. Okay, all right. The next is if you get 2 10s, which is $20. Okay. The next is if you get 2 5s, that's $10. But don't forget, folks, in this case, the other option is if you don't have the same bills, which means you win nothing. Okay, which means you really lose. Okay, so if you lose the game, you get no money. Okay, now we need to use the sideboard over here to do some rough work. Okay, because we've got to do some probability stuff here. Okay, so what's the probability of getting $40? Okay, well, it's the number of ways we can get 40 divided by the total number of ways. Okay, all right. So how do we figure that out? Well, how many $5 bills are there? There's 5. Sorry, how many $20 bills are there? There's 5, and we have to choose 2 of them. Right, 5 choose 2 over the total, which means how many bills do we have all together? 5 and 6 and 4 make 15. So 15 choose 2 bills. Okay, so plug that in and we get 10 over 105. I'm not worried about putting in lowest terms until I put it in here. So I'm going to go 10 over 105. Use your fraction button, folks, or divide each by 5, and you're going to get 2 over 21. All right, let's keep doing the second example. So what's the probability of getting a 20? Okay, well, how many 20s are there? There's 6, and we've got to choose 2 of them. So it equals 6 choose 2 over our total, which is 15 choose 2. Okay, plug that in your calculator, and you're going to get 15 over 105. What should we put that here? 15 over 105, and put it into lowest terms. It's going to be 2 over 35. Okay. I apologize. I looked at the wrong one. It's going to be, see, this is live video. Haha, here's an error. Okay, so 5 goes into 15 3 times. Oh, actually 15 can go into 105, so it's 1 over 7. Sorry about that. All right, now let's do the next one here. Probability of winning a 10. Okay, so probability of a 10 means how many 10s are there? There are 4, and we're going to choose 2 of them, divided by our total, which is 15 choose 2. So we end up with 6 over 105. Plug that in, 6 over 105. Lowest terms here is going to be 2 over 35. Okay. Now, we have to figure out what is the probability of losing. Okay? So, number of ways to lose. Okay? Well, it equals our total, which is 105 different ways. And we're going to subtract the number of ways you can win. So I'm just going to go back here, and I'm going to take these and subtract these. That's why I put them in here, okay? So I'm going to take our total, subtract the ways that you can win. So 10, you have 10 possible ways to win your 40. Subtract 15 possible ways to win your 20. And subtract your 6 possible ways to do your 10. So that gives us a total of 74 out of a total. So 74 out of a total 105 to lose. Okay, now generate a probability distribution for this game. So that is what we've done right there. We've done it in a chart form. So this is A right here. So A is done. Now B is a little harder. Okay, and unfortunately, let me just see if I can. Okay, do you know what? For me to do this efficiently, I'm going to erase this part just so that I can do B right across the line. Because you need lots of room, okay? So hopefully you already wrote that down. On my video lesson, if you pull out the answer, it'll have it on there. Okay, so my number B is what's my expected value? Or how much do you expect to win means you're looking for the expected value. Okay? So what you need to do is you need to multiply my chance of, so my winning outcome, okay, which is 40, and you times it by your probability of that, okay? You take that and you add the second chance. So I've got, to win $20, I've got a 1 in 7 chance, okay? Plus, I have a 10 times 2/35 chance, plus, here's the big one, 0 times 74 over 105. Really, when you show me that, that's fine. However, you know that's going to be what? Discluded, because 0 times anything is 0. Okay. Plug it in your calculator, folks. Okay. And you get 7.2380952, etc. However, it's money, right? How much you're going to win, right? So we round to 2 decimal places, so 7.24. So therefore, the expected winnings are $7.24. Okay, so from this game you expect to win that much money. Okay, another way you could do this, folks, is if you kept everything all in 105s. This might be easier for plugging the calculator. Okay, if I had everything as 105, right, and then I would say with the 105, I would say 40 times 10, right? And then plus 15 times, or 20 times 15. It's just a shortened way of doing it. You might like it this way. So 20 times 15 plus 10 times 6 plus 0 times 74. And then put them all over 105. Might be easier for you. Okay, and of course 0 times anything is going to be 0. Okay, so that would still give you 7.24. Okay, all right, next page. When the outcome is the number of points, a fair game, so if it's a fair game, it has an expected value equal to 0. So what does that mean? It should be E at X when you're done equals 0 if it's a fair game. Okay? When an outcome is the money you win, a fair game has the same expected value as the amount you pay to play. So for example, if you pay $5 for a ticket, then you should expect to win $5 with that one ticket. Okay? All right? But what we know in life is that lotteries are usually not fair game because they usually raise money and donate to charity, or they just make a lot of money for themselves. Okay. So let's take a look at this last example. It's a lottery example. These are popular, and I'd make sure you know how to do at least this type of example for your test. So study one of these. Okay. All right. It says a lottery has the following following prizes. So we have a grand prize of $10,000, and that's meaning one of them, right? Okay. We have two prizes of 2,500. We have 15 televisions, and we have 1,000 travel mugs. Wouldn't that be great to have a travel mug, folks? Awesome. Okay. And then remember, you also have the chance of not winning, and we're going to see what this is like. Okay. So the question is, A, is this fair? Meaning, when we pay $20, will our expected value be $20? Right? So let me do this, does the expected value, meaning overall probabilities with the monies you can win, equal $20? Okay? That will tell us if it's fair or not, because you paid $20 for each ticket, so then your expected value should be $20. All right. And then B, we're going to tie in some of the odds of winning something. Okay. So let's take a look. What is our random variable? Our random variable is the winnings. Sorry, my spelling has gone crazy on me. So the winning dollar value. So how much do you win? Okay. So we have many different prizes that give us a winning, including no winning, which is losing, and then we can think the probability of each. Okay, so hopefully you guys are optimistic. Say, I want to win the grand prize, and there's one of them at 10,000. So there's one prize over how many tickets are sold, guys? 5,000. Okay. Well, maybe we didn't win the grand prize, but what's the next highest value you could win? You could win $2,500. Okay. And the $2,500, there's two tickets because there's two grand prizes. Okay. And now, folks, I'm not putting this in lowest terms because guess what? It didn't ask me for a probability distribution. So I can just leave my fraction like this because it's not part of the answer yet. Okay. The next prize, folks, is 15 TVs priced at $700. So we'll just use $700. It's right here, Brooke. Sorry. Okay, and now Brooke's on the video. You want to say hi, Brooke?
Hey!
All right. There you go. Now you're famous. All right, so how many TVs do we have? We have 15 over 5,000. Okay. Next prize, we have, those travel mugs. $8 for the travel mugs, and they are 1,000 divided, there's 1,000 of them divided by 5,000. Okay. And don't forget, folks, the one we got to worry about is, hey, no winnings. Okay? So how do we figure out the number of ways to lose? We might need to do that on some rough work over here. So, number of ways to lose, again, I'm using the complement method, equals the total, which is 5,000, subtract the chances of winning. So, subtract one grand prize, subtract two runner-up prizes, subtract 15 TVs, subtract 1,000 travel mugs. So plugging that in, you should get 3,982 tickets that are lost. Lovely. Does that surprise you? Hopefully not, because lotteries aren't usually meant for winning. Okay. All right, so we had to do that just to get our probabilities, so now we can actually do part A, which says, is this a fair game? Okay, so for our fair game, we want to know, does the expected value equal, sorry, that can be a capital X. Does the expected value equal $20? I'm predicting not. Okay, because otherwise the lottery wouldn't do it because they need to make money. Okay? All right, so what do we need to do? We take to find the expected value, we take the number of ways. Well, actually, all of these are over 5,000. So let's do that shortcut way. So we put every fraction out of 5,000, and then we're just going to take the total prize and times it by the number of ways. Okay, so we're going to go 10,000 times 1, and then we will do plus 2,500 times 2, plus 700 times 15, plus 8 times 1,000, trying to fit this all in here, plus 0 times 3,982, which doesn't matter because guess what? That doesn't even equal 0. It equals to 0. Okay, plug it all in your calculator. I know it takes time. And then divide by 5,000 and you're going to get $6.70. Lovely. Okay. So, is this fair? No way. No, this is not fair because the expected outcome does not equal the price of the ticket, which is $20. Okay? Just think about it. If you take $20 and you subtract the $16.70, that means the lottery is profiting or making $13.30 per ticket. I'm going to take a moment. I'm going to plug that in my calculator if I can find it. I did find it. Good. So let's just, out of curiosity, there's only 5,000 of these tickets sold. So 5,000 times 13.30, they are making $66,500. Giddy up. Okay? So, lotteries usually aren't fair. Okay? All right. Now, remember that's per ticket. I forgot to write that down. Sorry. Okay. Taking a look at B, the second and last question for today is what are the odds of winning something? Okay? Well, if we know we lose 3,982 times, the total that we win are going to be this plus this plus this plus the 1. Add those up and that's 1,018 ways to win. Put that in lowest terms, which is 409 to 1991. If we take a look at this, it's roughly 500 to 2,000, so it's around, or roughly, a 1 in 4 chance, or odds, of winning. Most lotteries aren't that, are much different than that. That's pretty high, actually. Okay? Ladies and gentlemen, here's your homework today. Page 374, numbers 3, 6B, 8B, 9, and 10. Have a great day, and good luck if you're playing the lottery.